Hello, Antlang. Okay, so I'm gonna go make tea, and then we start. Okay, I'll be right back. Hello, everybody. So, hello, everybody. Hello, hello. So, what are we gonna do today? Well, first of all, tea is brewing, so I'm gonna go fetch it in a moment. Next, I mean, we merge a PR, improve the Opus package in all your code base, and then we just make a web a little bit better in general. So, I think the strategy is gonna be look at the workflows starting from, are you streaming on Twitch too? Yes, I am, Grid Slayer. So if you prefer Twitch, come on over. Um, there is a problem that I have currently with this chat application that I made. Not only I'm using it, but I made, where actually some of it is my fault, some of it is just YouTube being bad. But basically, YouTube chat only works for like a few hours, then it breaks. So if you want to chat, I recommend Twitch for now. Okay, so how long? Okay, 3 minutes and then tea is gonna be ready. So we have so much more work to do on Opus. Oh man. Oh man. Yeah. Lately I've been doing 8-hour streams and then working 4 more hours on my own on Awebo. So I've been working a lot on it. Yeah. Okay, I'll be right back. Okay, let's start. Okay, first of all, merge the audio PR. Take a look at it. Try it out. Remove prefix. Merge commit. Does Cloudflare use Zig? I don't think there are no official like statements from Cloudflare saying that they use Zig, but I have heard that they use Zig at the very least through um through Bazel. They have Bazel. There's a thing called Bazel. Is it rules Zig? No, that's not it. This is not it. Um, there's Bazel to do Bazel Zig CC, but I think they renamed it. Uber Bazel Zig CC is now Uber Hermetic CC toolchain. They debranded it from Zig. Now it's just Hermetic CC toolchain, and I believe that this bad boy depends on Zig. And Uber are not the only people. At Uber are not the only ones who use this. Also, I heard that people at Cloudflare and maybe some other big tech company depend on this. As for whether they are writing Zig programs or not, there I know nothing. No statement. I have no insider knowledge, so my guess would be no, at least not in any meaningful capacity. Okay, so we have the audio stuff, which has changed also the build script, which I think I want to tweak anyway. So mini audio, I don't think I want this as an option. We want it as an import. Is it a lazy dependency still? Pulse audio is lazy. ZWin32 is lazy. Mini audio is not. That's fine. Perfect. Then let's look at how this looks like in audio. Because in audio, we have to make a choice. Let's see how it goes. Yeah, I'll do it. I would do it like this. And then if I want to turn this on for macOS, I just comment that line, which I'm going to do now. So we keep it like this. And then there's also color. Okay, to be fair, you have to touch it in 3 points. That's kind of annoying, but totally doable. So do we build? We do. Perfect. Echo, echo, echo. Yep. Okay. Now to try it out, comment it out, comment it out. One, two, and oh shit. I feel like I lost my third thing, and now so device, audio, and the third one is color, right? Oh, there we go. That's what it was. Okay. Pause music because this time we want to hear well. Test, test. Yeah, it works. Nice. So congratulations. This works. So nice. We have multi-platform audio. So congratulations. To do to do to do to do to do. Okay. Good job. So next, we've done this. That was it. That was very easy. Already the news changed, but I want to undo. What? Hello? Oh wait. There we go. Okay, so this is done. Improve the Opus package. So yeah, about the Opus package. uh, hello, Yohoji. The next thing that we want to do is we take a look at the Opus package, and we need to fix a bunch of things that we didn't fully implement perfectly well. Actually, I'm gonna do this. Let's start from our noise. Our noise is essentially perfect. I just want to fix some small things. Is there any possibility that Zig 1.0 could break all the code that you've written? Yes. This is my only concern with starting to write something major in Zig. Of course, as long as it's a V0 project, then you should expect breakages. Now, the degree of those breakages, like not all breakages are the same. You could have breakages where you essentially have to throw away your code, and breakages where it's just minor stuff that you need to fix. Breakages in Zig tend to be not too bad lately. There are some obviously there are some like special cases. For example, the new 0.16 version of Zig has async IO, and async IO is a big change because you will want to opt into async IO. So there's that. But in general, all those things are like good opportunities for improvement. So um, some people do it. Mitchell with Ghosty. Ghosty is a serious project, and it uses Zig, and they update it. Tiger Beetle is the same, for example. There's more companies that do this as well. So I guess it depends. It depends on your sensibilities. So you might totally be right in saying that you just really don't want to do this at all, and so that's fine. But oh, thank you, Antlank. Yeah. Um, Wait a second. How many times were you defining that option? Once in build. Then there was another one down here? No. Anyway. Um mm-mm. No, okay, this was in main. Okay. Okay. So we're good. Oh, thank you. Uh, 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 uh. Okay. So what do we need to do in Opus? Basically, I messed up RTCD completely. So CPU info by ASM, this one goes true by default. Then, um, okay, I think that this is all good as is. With Zig build. Okay, can we Zig build Awebo? Let's do it from here with our noise as fork. It seems they were generally good. Okay. Okay, push this with minor fixes. Then so our noise is good. Then let's take a look at Opus. Oh boy. Okay, so Opus. I now understand the difference between presume and may have. And oof boy. Is there going to be is this going to be fun? So let's first put all the ARM stuff together. RTCD up here. And then we have x86, may have, and presume. Okay. Okay. Enable thread, enable deep PLC, enable OSC, enable OSC BWE. These enable hardening. I think it's disable hardening. No, they have enable hardening. Okay. Disable debug float. Enable float approximations. Okay, let's put all the silly header stuff at the top. Also, I'm thinking of moving these from a C flag to part of the headers. Although, oh, you know what? Let's keep it here. Okay. So we are gonna need more machinery here. So first of all, Opus, ARM, ASM. Let's take a look at some of this stuff. Hmm. Okay, we care about SEQ. Okay, ARM, ASM. If ARC enable ASM, disable ASM, disable assembly optimizations. That's the only thing that has ASM in it? No. No inline ASM for your platform, please send patches. Currently, we only have ASM for fixed point. Make use of ARM ASM optimizations. DNL. Is this as if commented out? Is the pound sign something that comments it out? Opus ARM inline media. Um, let's run out to generate and configure because I want to see what it does. Have Perl. So DNL is just a print. Print. We currently only have ASM for fixed point. What is this pound sign doing though? That is a comment, but I don't understand how, if that is a comment, how you can just comment verbatim. Okay. Fix debug. Debug fixed point implementation. Disable float API. Enable REST 24. Use 60 minutes of representation for fixed point implementation. What is it called? Enable REST 24. Help string disable fixed REST 24. Okay, you know what? Let's ignore this thing for now. Who cares? Let's do the ones that we do care about. Enable scalable quality extension, custom model, Custom modes, no. Custom API, no. Dread, okay. Deep PLC. Let's look at Dread. One sec. If enable PLC, yes, or enable Dread, or enable OCE, or enable OCE data, then you need to enable the PLC. Okay. Has float approximation. x86 64 ARM Arch, they have it. Others don't, I guess. Huh. Um, we can test this. So float approximation is wait, is there no test? Does it not use has float approx? Um, so this needs to be if. And the target result CPU arch equals arch. Actually, maybe we can leave a couple. And then we go on a new line. Is PowerPC. What were we looking at? x86 64 ARM Arch 64 PowerPC 34 PowerPC 32 IA 64. Uh-oh, we don't have a IA 64. Well, I guess we stop here. Okay. So okay, let's take a look at the runtime stuff. I think we're now at this point, aren't we? Intrinsics. Disable RTCD, disable ASM. RTCD support equals no, CPU ARM equals no. Okay, no inline ASM available for platforms with recent patches. Case OCPU in ARM. Hmm. So they have may and presume always set to 1. Trying to force enable ARM v5 eDSP instructions. RTCD support is define if assembler supports eDSP instruction. Define if binary requires eDSP instruction support. Okay. Um, so I think this is more complicated, and we're gonna need to take a look at this more in detail. So let's see if we can test this. So we're saying neon.prod, but there's also ASM eDSP media. Okay, let's try eDSP. There's no eDSP. The heck is eDSP? It's a library? No, I don't think this is it. Or maybe, yeah, what the fuck is eDSP? Make use of ARM ASM optimizations. Hello, Diablo. Use generic ARM v4 inline ASM optimizations. ARM 5E, ARM v6, ARM Neon. Okay, so we can ask for Neon, whatever. We can do ARM Neon. Okay, and then according to this, Opus ARM inline ASM. That depends on ARM v4. Okay, so you can do ARM v4 target dot 2 CPU features. Cortex Neoverse. Well, shit, none of these guys really match my expectation. What the heck is ARM v4 in relation to these things? It's not a specific model. Hmm. Architecture version. Yeah, but the thing of an architecture version is kind of ass. Uh, we don't have the concept of architecture models in here, I think. All CPU models. We don't have architecture versions here. So I don't know how I'm supposed to express ARM v4, ARM v5. I think that some of this stuff is opinionated in the sense that I remember there was a discussion about how sometimes you have this idea, right, of x86 v1, v2, v3, v4, for example, that are like these generic ideas, but they're not really standardized. They're just made up shit. So, yeah, express the feature you need. That is the problem because we don't even know what is the feature that we need. Because, for example, EDSP, that doesn't seem to like Neon. That's a set of features, yes. What the fuck is media? Like EDSP. Oh, EDSP seems to be an instruction, according to this. Media instructions. So is it okay, let's try ARM media. Is there a media instruction? I bet you that there isn't. There's no media. Any other types of ARM? Mm-mm. Oh, Maybe it's this. Has V4, has V6, has V7, has V8, V9. Could this be it? Five E. 5E in the list? 5TE. Ah. 5V5TE sounds so close to 5E. I'll take it. I think I'll take it. So I'm gonna say V4 has V4. Then we're gonna say 5E. And then 6. Then presume. Define if binary requires. Compiler supports. Define if compiler supports. Define if assembler supports. Okay, so here we can say Opus ARM ASM if the CPU is ARM. Inline ASM if the CPU is ARM, right? Because inline ASM is also no. Inline ASM is ARM v4. EDSP is 5E. And the other one is V6. Okay, in theory, maybe. Then the other features are okay, except that I need to understand the difference between may have and has. Why? I'm just trying to make a good package for Opus. Also, it may become relevant the day that we start making mobile applications. Hmm. Okay. Get CPU info by ASM disabled. Get CPU info by C method disabled. Custom modes disabled. Disable debug float. Yes. Enable hardening. Hardening should be on by default. Do we have hardening on by default? You have it on by default, yes. Although this should be more like this. What does it not like? This is actually correct. Something else is wrong. Expected expression found else. What are you talking about, man? Oh, there you go. Okay. So the presumed ones, like if binary requires, the presumed ones are not on by default. Okay, can I take a look at config help? Oh, there we go, the init and stuff. Okay, so far so good. What I don't understand is you have to disable this. But if you have to disable this, why does it not detect any of my CPU features? So I guess this is done by this program. No inline asm for your platform, please send patches. ASO CPU in ARM star. Oh, wait. So this stuff only supports ARM, not Arch64. That's actually fine. Opus check intrinsics. By making this program. Test if blah blah blah. Define if binary requires Arch64 neon intrinsics. Opus check intrinsics. Where is this thing defined though? Where is Opus check intrinsics defined? Like it's a thing that gets some stuff passed to it. Oh, this is the definition in Opus intrinsics.m4. Wow. Why are they using all these weirdo programming languages to do stuff? God damn it, man. In any case, if compiler supports one intrinsics, then program blah blah blah, result, no. If compiler supports one intrinsic with two, 3 equals 1, 3 equals 0. Jesus Christ. So you launch the program, and I guess this is success and this is failure. So success sets may and what's the word with the p word, presume. It sets may and presume to true on success, and on failure it sets presume to false and may to true based on something else. If compiler supports $1 intrinsics with two, $1 intrinsics with two, save C flags, AC line program 5.6. Link if else. If this one succeeds, AC link, AC lang program, and AC link if else. But what is the difference? The C flags have changed between this invocation and this invocation? If Opus presume is 1, then define to 1 Otherwise, RTCD support equals RTCD support SSC2. So I guess it's saying if we can test that we support it, then we set it to what? So if may have SSC2, then the fine may have to 1. I mean, yes. Okay, I see it. May have is, does the compiler support generating this stuff? And then presume is if we support it. Okay, so long story short, we want to set all the may haves to 1, I believe, because in Zig, all the may have, these are, okay, may have are compiler capability checks. Now, watch me, you know what? I'll keep a commented out copy around. Just in case, for a rainy day. You never know. Oh, they're not same length. Then presume are whether the architecture supports it or not. And then the question is whether you want RTCD or not. Okay. So I think RTCD needs to be a separate thing. And this one we actually keep. Actually, I think I already have it as a separate thing. Do I not? I don't. Hmm. Okay, so if we do it the way I was doing it previously, then this works like this. Actually, I think we're gonna have to do it for every one of them. Because if RTCD is enabled, then we don't include any of these guys in the main compilation. And then this is gonna be tough. I think this guy has to go inside. Alternatively, okay. So next we look at how we are adding stuff. For example, dread, we do this. If target is Art64, we add the Art64 stuff. There we go. If feature neon, if feature dot prod. Okay, we need to do the RTCD version of this. So if CPU features RTCD, now we're in business and it's complicated. So now it's gonna be add object. Name is gonna be Opus. What are we doing first? Let's do first dot prod. I think the dot prod is a worse version of neon, so we're gonna move it up above. We're gonna do first the more basic operation and then the more advanced one. So dot prod, then create module, target, and now we're gonna have to create a synthetic target. So the synthetic target is gonna be, let me copy the code that I have in here. B.resolve target query. So it's gonna be CPU arch. ABI equals target dot result dot ABI. CPU arch equals, in our case, this is arch 64. Then CPU model baseline. Then CPU features add std target R64 feature set. And here we're adding dot prod. Okay. OS tag is target result OS tag. That's it. Yeah, actually, ABI, it's better known here. Where's the business stuff? Okay, so we have an object, and then we can do object.root module, add C source files, and it's essentially this. And then I guess we can do it here. Basically, we add the object to our module. So to explain what's going on, runtime feature detection requires you to have in your final executable certain functions that are implemented using certain instruction sets. But in Zig, if you say that the CPU doesn't have a given feature, and the point is that then you need to have, so you're gonna need to have whatever function, like it's gonna be some neural network multiplication function. There's gonna be the normal version and then the version with neon in it. So what you want is to make an executable that has both implementations, and then at runtime there's going to be code. RTCD stands for runtime. I don't know, CPU detection, something like this. So it's runtime feature detection. So at runtime, the program will switch to the better implementation that it can use based on what the CPU supports. So the problem is if we compile everything all at once and we say that the CPU does not have neon, then if you try to use neon, the compiler will tell you, dude, your code has neon instructions in it, and you're compiling for a CPU that we're saying doesn't have neon. So to make this work, we need to compile separately in its own separate object file these individual neon stuff. Well, I did this for now for .prod, but I'm gonna copy paste this now again for neon. So you need to have its own dedicated compilation unit where we target the right kind of CPU, baseline one, and then we only turn on that specific feature that we plan to rely on, and then we link everything together after the fact. So this is let's call this dot prod obj. You know what? I'm gonna put this down here because we're gonna do both of them all at once. So we're gonna copy this. Actually, we want to copy everything. Place it here. It's gonna be neon. Instruction is gonna be neon. This is gonna be neon. This is gonna be neon. There we go. And so with this, we have created the two separate object files. And then we have linked them. Okay, so one thing, a bajillion more to go. x86, SSC41, AVX2. Well, otherwise, if RTCD, actually CPU features, then we're gonna need to do this 3 times again. So this is gonna be solid SSC object, SSC2. Also, we need to give them different names. I forgot. I think we should make a function. Yeah. Well, we should definitely make a function. We are copy pasting way too much. Way too error prone. So you're coming with me. Come on, man. Target arch. Okay, where are you lying? Oh, because it's under CPU. Okay. It's not an STD target, it's something else, but I guess I'll get there in a moment. Add C source file options. Oh, if we have the module, I think it's a pointer. But if we have that, then we can do this. No, a module doesn't have a name. But you know what? We can make it artificially though. We can call it Opus. No, we need name. Never mind. We need name, and we need and we can do it like this here, like this name plus plus. Oh shit. Ha ha ha. Hmm. Well, has to be like this. Although this kind of sucks. I think you can switch on the arch. Yeah. So this should be better. Okay. Let's see if this works now. So in here in RTCD, then we can do um. Oh, actually, we don't have to pass down mod because we can just return the object. That is much better. Step.compile. Okay, so we can do mod.add object rtcd object b target Name is going to be Opus. Um, CPU Arch feature. Prod. And then this, where we essentially do this. What do you not like? Oh, yeah. Yeah. And this is not too bad. So then we do it again for Neon. Oh shit, this is the SSC2. Wait, where the fuck am I? Oops, wrong place. So cut. There we go. Arch 64, .prod and Neon implemented. Okay, now we can go down here and do the same for this guy. Okay. So this is going to be x8664. Feature is going to be SSC. And the thing that we're going to do in there is this. SSC2. Okay. Then SSC for 1. And then AVX2. This is much more manageable. Okay. Then there's PLC. Okay, now we're in CELT. There we go. If CPU features dot RTCD. We're doing the Neon stuff. Neon, the Any10 stuff, I'm gonna leave there, but comment it out because it sucks. These guys, this is CELT, right? Not Opus, yeah. There you go. So this is RTCD for Neon in CELT. Then there's x8664, which has a few variants. Okay. Oh, this one has normal SSC. Wait, did the one above not have normal SSC at all? There was no and net normal SSC. Is this true? Hmm. Yeah, there's only a net SSC2, SSC for 1, and AVX2. Okay. Okay, so let's continue down here. Um, if wait, this is not, this is done. This is the one that we're looking at. Okay. We're gonna need SSC, SSC2, 41, and AVX. Okay. So, are we still in Celt or is this Silk? Still in Celt. x86 64, SSC. Then SSC2, SSC41, and AVX2. Is it really AVX2? Because it doesn't have to in the name. Am I messing this up? Um, Peach AVX. Yes, it says AVX2. So, okay. Okay. So next is Silk. There we go. SSC for 1 and AVX2. Okay. What were we saying? SSC for 1, AVX2. Okay. So, well, this is it. Let's see how it goes. Zig build. Ooh. Slice being concatenated must be comp time known. CPU arch. Yeah, we can make that comp time. And feature as well. Oh, you know what? Actually, I think I'm right. Okay, normal build works. Let's enable RTCD and see what happens. So, dash RTCD. Actually, let's first cross compile. Yeah, there we go. 360 errors. Oh, only those? Mm-hmm. Ah. So I think we broke it because this was working before. How did I break it though? Because RTCD should be. I didn't touch anything. I should not have touched any of the existing behavior in theory. Let me look at the diff. Oh, wait. There's one thing that we should take care of. Let's reset the Zig package. Let's rebuild. Because we did things to Zig package and that might have consequences. Okay, but that was not it. So RTCD, either you turn it on or it's false by default. And so if it's false by default, then it's just going to be true end. So this is not going to change these other things. So we're good. These guys have been reshuffled, to be fair. I think maybe setting this to true unconditionally might not have been a good idea. I think that this is what caused problems. The problem is so the problem is that these stupid flags need to be defined. They need to be defined when we are um, building the relative thing. But I guess we just cannot set them true unconditionally. So I bet you that if we now turn them all back to where they were, now cross compilation should succeed. Maybe. Yeah, it does. Um, the problem is that we cannot use these things when creating RTCD stuff. Yeah, yeah. Yeah. So we need those mayavs to be true. I think we can just hard code them to true in that case. Maybe. Hmm. I need to think about how to do it in a way that makes sense. So how do we do this in a portable manner? Oh, that is actually annoying because there is even something that we don't specify in here. It's something we specify at the usage side. Oh man, that is so annoying. What's in our C flags? Oh, just bullshit. Mm, I don't know if this is gonna work out. Hmm. Man, how many of these there are? Holy shit! I feel like I'm going insane. Have I not deleted those already? Hello? Okay. Is this gonna do it? It should, in theory, because the only thing that we changed is RTCD. Okay, now it's time for the RTCD stuff. There we go. Config.h file not found. Right. Hmm. Mm, 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 mm. Oh man, let's go fix all these things. Config, config. Let's see. I really give. I would really give Z a go. Nah. Vars a little bit more polished in regards of compiling errors. It looks so promising, but I'm hooked on Rust compiler and the nagging. I mean, just never write wrong code, and then you won't have to. Then you're not going to be affected by compiler error messages. um, what else am I missing? Oh, these guys. In any case, yeah, the error messages. Personally, I think they're fine nowadays. Could they be made better? Sure. Uh, but they're generally fine. So my instruction is kind of sucky because some things need to return more stuff. You know what? I think I'm gonna take this out and we're just gonna do it manually everywhere. So instead of just calling this, because this guy also does this, does the include path stuff, which we need to do also to the object files. Hmm. Yeah, it sounds sexy to be able to just do this, but man, does it suck. Now, okay, let's double down. Let's double down on the imports. I should call them includes. Okay, it's the includes now. So, for example, this guy has this. Mm, this is not exactly a delightful experience, but what can you do? Okay, so are we done? No, there's only one last RTCD. I think that we're still missing some more headers because I think we need to provide probably all the application headers. So I'm just providing the obvious ones, but there's gonna be more that we need to provide. Oh, there's more, right? Okay, we got to the top. How we're doing now? Special lazy path found void. Oh, you're right, because I should not be copying the whole mod.add. Oh no. I copied way too much. Uh, how do I get the docs for a hash map? Um, is it a string hash map, an auto hash map? I'll assume it's an auto hash map unmanaged. Um, holy shit, this guy doesn't tell you anything. Really? How about we do a string hash map? Uh, yeah, the docs are not particularly nice, huh? So let's see. Yeah, it doesn't have, the docs are not particularly good at this. So here's how you do it. Somewhere in your code you have your definition, right? std dot auto hash map unmanaged, whatever. Go to definition, follow the definition, and you'll get to the implementation, which is it's in this file. Man, okay, let me zoom out. I don't have any IDE features. That sucks. Well, you can do the same with code search. You should have those IDE features though. They are very good. Go to definition is really, really good. So hashmap.zig contains the implementation, and you can see public methods. Now, Those should be visible from here, though. Or maybe they were never, really? Yeah, I guess they were never. So yeah. In any case, the problem is that the docs are not complete, and they are not able to punch through um, generics. So the problem with the hash map is that it's generic. So right now, if you want to see the interface, this is how you do it. You look at the um, you look at the you have to look at the source code. I don't think there's a better way than this. Yeah. I enjoy running all my machine. But you can disable everything else if you want. But it is a regression? Oh, interesting. Yeah, you're right. Because I also had memory that those things were available. So I don't know what happened. Yeah, it must have regressed. In any case, it keep everything else disabled. It's fine. Don't have autocomplete on. You can keep it off, but go to definition is useful. Like there's really no downside to go to definition. It's just good. You will need to look at the definition of things, even if things that you yourself defined, and being able to do that quickly is just good. Do it. It's useful. Okay, let's see how I am doing. Yeah, but I would still argue that it's nice, even if you don't have, even if you were to have docs. Okay, so we're still missing a bunch of things. Oh, we're missing libc. Kind of an important thing, huh? Our object file needs to link libc, so let's go do that. Where do you define libc in the root module? Link libc true. So this should reduce errors a little bit more. And now we can continue with this stuff. So pitch AVX is missing Opus defines. So Opus defines. Okay, let's see. It's basically so here's what I want to do. I think I want to change this Opus to upstream. Okay. Then what are we doing here? Pitch AVX. Okay, here. Well, not here. Here, this guy wants some more imports that we don't have. And it's probably this guy. These guys. How are you gonna do this? I guess we can start with the include. We do them one by one so that we don't overdo them. I think we're probably gonna need more imports. Okay, let's see. I just don't want to import stuff that is not needed. Okay, now it needs pitch.h. Where is pitch.h? I bet you that it's in celt. So it's probably needs to be like this. Include, which is the very generic includes, then the celt stuff, and then the celt x86 specific stuff. Always inline function requires target feature FMA, but would be inlined into function blah blah blah. It is compile without support for FMA. Well, there we go. So it turns out that you don't specify one feature, but you specify a list of features. Oh God, FMA. Hopefully we have FMA. Okay. Feature and then feature depths maybe. Oh, you know what? We can keep it one feature and then we can add its dependents. I think we can do it like this. I mean, we know what these things are. So we can say, okay, let me undo also these changes here. So this is fine. But then down here we say, okay, if it's Arch64, no, right now we're doing this, right? So we're saying, okay, what you got? And so we say, if it's AVX2, then we return AVX2 and FMA. If it's SSE, if it's SSE2, if it's SSE for 1, oh, why are we in flow mode? I don't want to do this. Wait, there we go. I think this is it. Okay, let's see how we do now. Oh, we reduced the number of errors. That's good. Okay. So we need to do more of what we did just now. So we did good. We just need to do more of that. I think starting from the top might be a good idea. Including DNN. Okay. This Silk has included Silk and also Celt somehow. Okay, these are some easy ones. Up here we have include. Okay, let's see how we're doing. Can we see what the app looks like? Sure. Oh no, I introduced errors or something. Too many errors. Emitted stopping now. Unknown type name, unknown unclear identifier. Okay, we're still missing some stuff. What the application looks like? Application looks like this. Oh, I had already one open. There we go. So the application looks like this. Test, test, test. I can connect to a server that echoes back. That is not interesting. I can turn the camera on. That's a webcam. I can turn on screen share. This is just local playback. I don't have the ability to send video over the network yet. Um, but um, but voice over the network works, and it works really well. I have also the ability to survive packet loss, and I have noise removal. So I have some stuff. Right now, I'm working on improving. I need to enable architecture specific optimizations of Opus, and I need to do it correctly because the new Opus codec has neural networks in it, and they need to run fast. Otherwise, there's just no way to make to uh, have the audio work well. So that's what I'm working on right now. Okay, so inner product AVX2 wants SIGPROC FLP. So this guy wants FLP. So where do we get FLP from? Actually, it's find. What's it called? It's in Silk Float. Oh, so we want also Silk Float. Let's see, 121.42. 121.42. Oh no. We have maybe solved some things. Now we're missing arch.h. Silk macros wants arch.h. Okay, where's arch.h? In Celt. Right. There's this thing where these libraries, they all depend one on the other. It's so dumb, but okay. I mean, it's not so dumb, but it's just, it is kind of annoying. Okay, progress. Let's go. 21, 21, 21, 21, 4. Ah, still there. Oh, of course. Here we need also celt slash x86. I bet you. And here, same. And up here, we need celt arm. Error file not found, celt arm CPU. Oh, no, that is worse. We don't want that. We want dot. There you go. Macros.h file not found. Okay, this is basically some of the stuff that we already did. We're gonna need to do also above. So these guys are fine. These guys need some love. So this guy probably wants dot. Oh, now he wants math ops and arm math ops. It's in cell. Wait, who is it that wants that? Oh no, they have it. The problem is that they are referring to a type named float 32 by 4t. Um, float 32 by 4t, huh? Hmm. I think that this type is not defined by this library. I think this type is just available to you if you have the right thing available. Who is it that has this? You need to have neon. So if you have neon, you have it available to you, for example. Okay, so maybe I failed to enable neon somewhere. Okay, who has this problem? So MathOps ARM has these, and this all comes from Self LPC SSE 41. Oh, so this guy should also be available with SSE 41. Okay, in theory. Uh, let's take a look. Where is it? There we go. This guy, but in this version here, SSE 41. Is it because when you have SSE 41, you need also to assume prior SSEs to have access to that type? Hmm. Or no? No, I think we should look at the contents of this file. Oh, no, 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 no. I get it. I get it. No, it's on me. It's on me. We cannot give all of them these flags. Oh, no. Okay, if it's SSE, it's C flags and then this. If it's SSE2, okay. That's all because of the header files. That is so annoying. Is that the type not found? Okay. Whew. Okay, better. So next is what? OP, CVTE, PI 16, EPI, M64. The fuck? from incompatible type int. Okay, we are getting so close. So the only thing that is pooping itself up is these SSC41 files. It's only these SSC41 files. So either we're missing an import or we have messed up something, but it's like so close. SSC41, NSQ SSC41. These guys, but the RTCD ones. Okay, so I did set the RTCD flags right. We did include stuff, but there's a disagreement on types. From incompatible type int. So we think that this is an int type. Well, let's take a look at the definition of this bad boy. Define. So x86 CPU defines this. Right. And we do include x86 CPU. They have it as an import. Yeah. Okay, let's look into this file now. So that is line 107. Oh, at the very end. So how is this defined? It's an wait. If defined clang. Starting line workaround. L if. And if and if. So we're inside two ifs. Bro, these definitions are impossible to fucking read. Holy shit. There's an if. There's a nested if. This if ends here. This if ends here, so that's not it. This opens. Here's an else. So if, else, and if. Oh, so this is in no, I was about to say this is uh not under condition, but it is under condition. May have SSC2. Include Opus defines. I'm confused. So I'm giving them SSC for 1. So this file should do the right thing. They have SSC, and that is all okay. In our case, it's SSC. I think that the problem is that you need to have, if you have SSC 4, you have also SSC 2. You know what? I have this suspicion. Let's test it. Okay, we're left with macros.h missing. Which is in Silk. This is pitch SSC. Pitch SSC is missing Silk. Which one specifically? SSC for 1. Yeah. Oh, it's not. Okay, so I guess all these guys want Silk. It worked. Okay, there's a couple problems with R64 now, where we're missing a couple more things. Celt Neon Inter. Oh yeah, this poor guy. I didn't give it all the imports that all the other ones have. There you go. Poor guy. Static declaration of Opus select arch follows non-static declaration. Arm CPU.h. It means that either this guy or this guy is bad. What if I don't give you salt? No, I think that it does want salt. Yeah. Okay, so I think we need to look at the macros. Okay, so this else if Opus have RTCD and Opus ARM ASM or Opus may have Neon Inter. So we're entering the else branch and we should not. We should be entering this branch down here. And we're not entering this branch. Actually, there's also these. Have RTCD. This is the x86 stuff, which we don't care. So there's this. If define Opus RTCD and Opus ARM ASM or Opus ARM may have Neon Inter. So here it's Neon. So it's pitch Neon Inter, right? Where this whole situation starts. Mm, it is while building Celt. It's ARM CPU.c. Where's ARM CPU.c though? Up here. Alt ARM. Sorry, wait a second. Is this an RTCD thing or not? Because it might not even be an RTCD thing. Yeah, okay. It is RTCD. Okay. May have. Um, why is this not okay? Opus have RTCD. Yes. Let's double check. Opus have just the basics. Opus have RTCD? Yes. ARM ASM. Oh, wait a second. Also, oh, I think I got it wrong. It's not may have Neon Inter. It's may have Arch 64 Neon Inter. Now I'm confused. Why are we getting in there with Arch 64 Linux? Arch 64 does not succeed a is ARM check, right? Yep, it's not ARM. Okay, so hmm. So it is correct that we don't enter here. Else, Opus Arch Arch mask 0, Opus inline. Maybe it's the Opus. No, but the static definition is not decided by us. Also, why are we're inside of an outer if if so there's an else if there's an else branch. This ends. Oh, is this end if for the if and def? CPU support H, okay. Does that mean that we shouldn't be including ARM? No, I think it's not a problem with this guy. Yeah, the problem. Okay, so we know for sure actually where the problem is from. We are looking at armcpu.c, so it's this guy that fails. So we're not supposed to put this here, then. Let's look at this one. Maybe this one will give us some more information. Maybe the other one is. Maybe this one is correct, and this is the wrong one. If defined may have. If defined may have. If defined may have. If defined may have. If defined Opus have RTCD. Okay. So if we have Opus have RTCD, we define this function in this file. While in here, we said that it is static. Also, we need to understand what the fuck is Opus inline. I guess basically we expect one of these two to be true. If this is true, we always expect one of these to be true. Hmm. Yeah, you know what? I think that we need to pass the other one. Oh, presume. There's no may have. Hmm. Oh, there is. Hmm. Actually, I'm not even 100% sure what I'm doing. I guess the multi-platform auto calls. I merged the PR. So, oh, there we go. Look, now we. Oh wait, no, we need to run the RTCD one. Um, we. Fuck. Um, I merged the PR, so they're on. Windows, I believe, is still not working because of a Zig blocker, but Linux should be up. So I got stuck in this puzzle, and I don't know what the right answer is because I'm confused about the relationship between these things when it comes to ARM versus non-ARM. Although here's what we should do. So Neon is R64 Neon. Oh, there's ARM Neon. Okay, there you go. I'm thinking that dot prod is also an ARM thing, not an Arch64 thing, but I don't know. Okay, that gets us to call to undeclared function celt inner prod neon when doing celt neon inter. Which is defined in pitcharm.h. And this is on only if ARM may have neon inter. There's also may have neon. Celt neon inter.c. Call to undeclared function. Um, do you have time? You will have the Awebo meeting, or did it already happen? No, it was an idea for the future. Not yet. Okay, and then now with this, we're back to Opus Select Arch being defined twice, where one of the two shouldn't be in. This is one. I think this is the one that shouldn't be in. Oh, yeah, actually, why are we not entering this? Opus have RTCD. Opus may have neon inter. We have this. So we have RTCD. We have why are we not entering this case here? Also, wait, are we back to ARM CPU? Yeah. So this is okay. So this is a main a problem with the main program. Okay. Is it because they not RTCD? Oh yeah. Okay, I think I get it. This is like RTCD or okay, I think I get it. It's kind of like okay, let me fix it this way. Let's see if it does work. Yeah, motherfucker, I knew it. Okay, the problem is that if I do it for everything, it's not gonna work. Will this work? Okay, it does. I did not expect this. Okay. So holy shit, we made some progress. Whew. So then let's try to build, let's do the Awebo CI with Opus. If Awebo passes the CI, then we can commit the Opus package. Okay. Local build as a final sanity check. Hmm. I should go get my tea. Okay, we're running. Okay, test. Yay. So we haven't broken it. Um, Zig build H. Show me all the options. Okay, we have to do this work though. So we need to go in build Zig. So you can close. I mean, we already have it open, so this is just for the README. In build Zig, we need to do the work to make what I mentioned real. Go into the zone file, call this upstream. Then we have the module. Oh my god, Stealth and Silk produce static libraries. That's disgusting. The typo, thank you. These guys produce libraries. I mean, that's fine. Okay, let's do it like this. So static dynamic. Uh, b.add install artifact lib install artifact dynamic library. Okay, we return the module. Same here. Then let's do the header stuff for each of these guys. Does these guys, do Silk and Stealth have their own header files even? Then include of Opus, you just have Opus stuff. What about Silk? Oh, Silk doesn't have, wait, what? Like a silk.h? There's no silk.h? Wait, you're just main.h? This is it. Maybe. Actually, I don't know. This guy imports way too much stuff. Although this does look like the main API. Oh, there you go. Reset decoder. Init decoder. And if. What's the if? Wait, what does this and diff relate to? Not these guys. Not this guy. Not this guy. Not this guy. Not this guy either. There's a floating end if. Oh, it's the if not def. Okay, that makes sense. Bro, this guy wants a lot of header files. I don't even know. Is this even supposed to be accessible? He just wants a lot. We can try. I mean, let's see. So we can do underscore equals b dot add config header. No, what am I doing? B dot add translate C. Actually, target equals target. Uh, nah, I think it's fine in this case. I'm gonna use Clang for now. And we need to add a bunch of include paths to this guy. Well, at least one. Otherwise, it's just not gonna work. Silk headers. Okay. So this is silk headers. I don't know how far we'll go with this, but okay, let's see if Salt is any better. Okay, what's in Salt? Um, hello, am I blind? Yeah, I am. Okay, so does this guy have? So there's no salt.h, I imagine. There is. Wait, okay. Are we sure that there is no silk.h or some obvious, like under float, for example? Is there anything in here? Main FLP. Oh, these are the floating point versions. I see. Okay. No, it just called main. Okay, so they just call it main instead of. They probably were not used to how people do things in C, I guess, at the time, or they wanted to innovate regardless. Oh, this guy wants a bunch of Opus definitions. Okay, but at least we have the Celt API, I guess, maybe, I think. At least some of it. Okay, so Celt.h. What does Silk want? Me.h. Silk doesn't seem to need. Well, there is no. So there is no mention of FLP. So it means that this guy doesn't have floating points, floating point operations. I feel like exposing these headers is just a disaster. I think it's just a disaster. Um, it really just seems a disaster. Hmm. Okay, so here's what I think we should do. I think we return them as a module, yes. And we just don't even bother creating libraries for them. They seem too unusable in isolation, so let's not do that. And then in Opus instead, we do it correctly. Technically, we should do Opus custom, Opus multi-sim, and projection as well. But we're not going to bother for now. Headers. I mean, honestly, you know what? It doesn't even take much. We might as well do it. So like here we do Opus custom. Although we don't have, oh, you know what? The problem is that we don't have the other flags wired in, so never mind. Okay, Opus headers, name Opus, root source file, get output. There we go. Library, Opus static, Opus dynamic. There we go. Mod link library, no. There we go. Libopus, libopus de lib. These guys. Perfect. Okay, let's see if we still work for Awebo. Artifact name Opus is ambiguous. There we go. Oh, that is a problem. You cannot give them the same name if you want to use them as an artifact. Oh, that sucks. The good news is that we don't care in our case because the link library can we add test. Okay. Let's look at the CI. I'm gonna run out of disk space soon. I feel like my caches are gonna blow up. But it seems that we are good. So this can exit for sure. Here we're doing fine. So this seems to be it. Okay. So we are doing fine. Uh, so that means that we need to fix the README and then we can push this. So here's the typo. Okay. Updating Opus. Okay. Oh man, what an adventure! It's been 3 hours and a half. All of it essentially spent hacking on Opus, but it should be better now. So in theory, if I did this correctly, it means that when you're cross compiling for another architecture and you have RTCD on, it will try to make good executables. So that also means that in Awebo itself, we want to make our RTCD conditional. It works like this. If target dot query dot cp dot is native CPU, if in the query we were asking for the native CPU, then it's false. So essentially, it's not this. Because if you're building for the native CPU, then you don't want RTCD on. And I think this is true for this guy. For this guy. For this. What? Hello? For this guy and for this guy. I don't think I want those assertions. I don't think I want those assertions anymore. Okay. So we'll see I one last time. Oh no. We fucked something up. We totally fucked something up. Oh man. Okay, this seems silly errors though. These all seem stuff that we can fix. I wonder why we did not end up hitting those earlier though. Sorry, what if I do fork opus? Don't tell me that this guy works. Okay, that's more like it. Okay. So when compiling nnet SSC, oh yeah, we tried earlier, but without RTCD on. That's the problem. Okay, so we're doing nnet SSC for x86, and we're missing stuff. RTCD. Arch macros. It's underselled. Error celt x86 vCPU file not found in NetSSC, right? Because then they also want dot. CPU support and net neon. This also wants celt. And don't tell me, it also wants dot. LPCnet file not found AVX2. Under DNN, and this is NSQ. NSQ AVX2. And this is missing LPCnet, which is under in DNN. PLC data. Neon is missing PLC data.h. PLC data, I think is not upstream. I think it's in PLC model. I think this is it. Huh. How do we add this conditionally? That is annoying. But wait a second. I think, okay, so which file wants that? plcdata.h, nsq del deck neon. Are we not under the branch that says that we do have PLC? For sure? Oh. 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 Hmm. Oh, whoops. Yeah, I have to do it like this. lpcna.h for pitch neo inter. Although I think that this thing here might be necessary also in other RTCD stuff in here. Okay, pitch neon inter. What is it looking for? LPCnet, which is DNN. Okay, this time is building more, so some more stuff is fading, but some started building. Undeclared function v get lane f32. Oh no. Use undeclared identifier float 32. Oh no. I thought we beaten some of that stuff. I thought we've beaten some of that stuff. We still have a bunch of issues. Oh no. Hmm. Hmm. Some stuff is not configured as it should. So pitch SSE imports this guy, and then it says unknown float 32. That's not good. Pitch SSE 2. Why does it have this problem? Pitch SSE 2. Is it because you have to do this as well? Hmm. I think we also need to figure this stuff out. Hmm. Oh. Oh, here's a big mistake that I'm making. Here's a big mistake that I'm making. Every time you may have one of these, you also presume to have them. Wait a second. more than this, more than this, every time you may have, you also presume have, of course. Let's see how this goes. Okay, every single one failed. Let's see how. So this one failed because it's missing implementations. Okay. This one failed because it's missing implementations. Okay. Same. Same. Okay, and there we go. Peach AVX is missing LCP net. Okay, I think that every single failure now is a linking failure or close to. So linking failure, linking failure, link failure, link failure. There's a few of these more. And the clear function we get lane F32, VQSSC2. This guy. I guess it's an intrinsic. It's an ARM neon intrinsic. Wait a second. What? What? Okay, I think it's because of the may have. Um, so may have neon is actually RTCD. Well, is ARM and RTCD or neon. Um. Hmm. Oh my god. We're still erroring out so much. Okay, I think with this every single build has failed. Wait, are we failing now in our noise? Configure to use x86 RTCD, but no CPU detection method available. Reconfigure with disable TCD or send patches. But no CPU detection method available. Okay. Set neon inter. Call to a declare function set inner prod neon. Okay, let's start with x86 64 Linux. This one fails, right? CPU info by C, CPU info by ASM. Okay, CPU info. I think we always turn on CPU info by ASM. If defined and defined PIC. CPU info by ASM. Do we not have here something like that? No. Okay. CPU info by ASM true. Okay. So now this works. Windows. COF does not support linking multiple objects into one. Oh. Mm, does not support linking multiple objects into one. So that means that we cannot do add object. We have to do add library. Fine. I don't believe it. There's no create library. Okay. So add library. Static linkage. Okay. Are you happy now, Windows? We have a happy Windows. Is Linux still happy? Okay. Is Arch Linux happy? Nope. Right. This is the one that has this issue here. God damn it. Out of curiosity, what if I stop doing weird things down here and I only do this? Okay, so with this, we're missing a definition for inner prod neon. I think I saw this already. So the problem is that this is defined here. But for this, we need this. Okay. Why do we think we need this? Because it's used by Salt Neon Inter C. Okay. Is this guy right? It seems so. Is this the correct combo? No. Yes, maybe. This now flips us to the previous error. Static declaration. Right. I'm not figuring out exactly what is the combination of things that I want. Um, I heard Discord didn't turn profit for like 5 years. Just keep on investing. Is that true? I don't know. You're talking about the last 5 years. Has Discord ever been profitable? Startups don't really try to be profitable. They just try to flip a return. As weird as it might sound. So why are we not getting in here? Like, ARM may have Neon Inter. Opus ARM may have Neon Inter. Okay, it's so weird. We are entering this else branch, even though we shouldn't. Right? No. Okay, I think we fix it's ARM CPU.c. It's ARM CPU.c. I think. Okay. Okay, I think I get it. I think that's how it is. Let's see if we made any progress. We're linking. Okay, CI time. Hello, crypto code. Jesus. Okay. Now, here's what I want to try. Am I supposed to also keep these on? Or is that a problem? Do those definitions make any difference? So CI wise, they don't. Build native. You know what? This is, by the way, this is teaching me that these guys here, like ARM Neon doesn't exist. It's just Neon, and it's not RTCT and R64 or ARM or ARM. And down here, this is just Neon. Now watch me fuck up my build again. Oops, I forgot fork. Yeah. Yeah. Okay, I think I got it. I think I now understand what the shape of things should be. And I think I'm overly complicating it, but I'm not gonna fix it now. Jesus. Okay. Are we good now? Yeah. So we did this. Um Okay, I would say that's my need. Okay, what an adventure. So, what did we do today? Well, we merged a useful PR. Then we spent a lot of time trying to get Opus to do runtime feature detection correctly. I don't know yet for sure if it actually does 100%. So we'll see, I guess. But for now, it seems that it is kind of doing something. Our build is not broken, at least in theory. So yeah, we didn't end up polishing any Awebo flow yet, but we made progress towards that. That's for sure. So today was a good day of janitorial work mainly, I would say. But it is nice having the packages in all your code base become more serious. They stop being just an initiative, tentative, super crappy package to being more serious about things, and that is good. So yeah. Um, this being said, I think I'm gonna stop here because it's dinner time, and yeah, tomorrow we're gonna work on Awebo proper. So thank you for hanging out, and I'll see you next time. Let me see if I should raise somebody or if I'm gonna be lazy. I think I'm gonna be lazy. Yeah. Thank you all.